Alright, the following video will cover electronegativity and how it's used to determine polar and nonpolar covalent bonds. As a reminder, when we talk about covalent compounds, we're talking about sharing of electrons. Now, initially we established that all electrons are shared equally with covalent compounds. Then you were introduced to electronegativity and told that that's not the case. And so here's a review of this process of figuring out if it is going to be polar, where it's an unequal sharing of electrons, or nonpolar, where it is an equal sharing of electrons. And so what we're looking at here is we're looking at a chart that has the electronegativities for a group of common elements here. And so the electronegativity tells how strongly the attraction that element has for its valence electrons. So if you look at fluorine, for example, here, it has a electronegativity of 4.0, and that's the strongest it can be. So fluorine's not going to give up its electrons very easily. Whereas something like cesium with 0.7 has a really small electronegativity and is going to easily give up those electrons if given the opportunity. So to figure out the electronegativity and which element is going to have the electrons more often, if it is a polar bond, we're going to do a subtraction. And so let's take a look at a bond between hydrogen and fluorine, for example. So we're going to take the 4.0, that is fluorine, and we're going to subtract hydrogen over here, which is 2.1, and that gives us a difference of 1.9. Now I can look this up on our chart for the differences in electronegativities to determine what type of bond that is going to be. And so when we look at this, 1.9 falls into this very polar covalent compound area. And what that means is that one of the atoms involved in that bond is going to have the electrons more often than not, even though they're sharing. In this case, fluorine has the larger electronegativity, so it is going to have the electrons that are being shared more often than hydrogen is.